Vanakkam Makkale and healthy afternoon, everyone. Thanks for joining me the session today. So let me share my screen first. Okay. Are you able to see my screen? I'm
not.
Yeah,
Yes.
yeah,
right?
we can.
Okay. So, okay, I'm set. So today we are going to discuss about techniques for text pre-processing in NLP. So we'll start with a small introduction about the topic. Usually text data contains a lot of noises in various forms like emotions, punctuations, no text in a different cases. So if you are trying to feed the same raw data to the model, it won't give the it won't be effective, and a lot of performance issue it would cause. So for that, we are using text pre-processing is a method here to clean the text data and make it ready to feed data to the model. Like, it will clean all the unwanted stuff, and it will feed the cleared text data to the model. So does it really required for NLP? Yes, it is, because otherwise it would cause performance issues when we go for NLP algorithms and other things. So for that, we are using certain pre-processing techniques. So we'll see what are all the techniques. So here I have listed out the techniques like tokenization. Tokenization is nothing but like we can split a text into word by word or sentence by sentence. So this is called tokenization. There are a few more techniques for this. We call it as rule-based techniques and statistical tokenization. These are all the techniques we can use for tokenization. Then stop word removal. We'll see one by one in detail in coming slides. So I'll walk you through all a few techniques in a quick detailing stuff. So case normalization here on fourth step. So that is the name itself suggests that, like, we need to normalize the text, like, everything should be in a lower case for our use case. So remove punctuation, same here, like we'll need to remove all the punctuations in the text data. The lemmatization and the stemming, I'll not go in detail in the coming slides. And then handling numerical data. Sometimes we'll see the text which contains both alphanumeric stuff, like which contains text data as well as numerical values. For example, phone number and other things and all will be included in that model, in the data. So again, that last one, remove white spaces, that would remove unwanted spaces in the text. So these are all the techniques we are going to use in our NLP. So we'll see one by one. Before that, a couple of libraries I have mentioned here. So there are many libraries and algorithms used to deal with NLP based problems. I mean, by default, regular expression, RE, is the one library which is mostly used for text cleaning. So I have also mentioned a couple more libraries here. NLTK, Natural Language Toolkit, which is Spacey. And this is also one of the latest library we are using, that too in production environment. We can go with Spacey library. NLTK is an old library used for practicing NLP techniques by beginners. So these are all the two libraries available. So we'll delve into the topics one by one. Here I start with stop words. So stop words are the most commonly occurring words in a text. Like, we should not provide any valuable information. If you take the examples here I have mentioned, they are this, that, is, was, these things and all, we call it as stop words. So we can have the common library to get the stop words from Google, or we can define our own stop words as a dictionary, as I mentioned here. We could also define our own dictionary. So here we can already, they have come up with 180 stop words they have added into the library. If you wanted to add a new one to the existing stuff, we could go ahead and use the add method, and we can add a new stop word into the existing list. So these are all the example I have given. Like ain't can be stand for like or not. Similarly for aren't, didn't, and all we'll use, right? So we have to make clearly and make clearly to the model, like we have to expand these shortened words, like ain't should be or not. So we have to replace all these things based on the dictionary values. So this is what for expand contractions we'll do these mapping stuff we have to do for expand contractions. So this is for the second step, expand contractions. And then the next would be stemming, stemming and lemmatization. Like we could know it's a process. Stemming is a process to reduce the word to its root stem. For example, if you take run, running, runs and all, we could see the base word is run here. So this is called stem of the word. So basically stemming is used to remove the prefix or suffix from the word, like ing, yes, es. We could say a lot of prefix and suffix stuff here. So NLTK library is used to stem the words mainly. But we cannot use NLTK for production purposes because it is not so efficient technique, and most of the time, it stems the unwanted words. So in order to solve this problem, we have an advanced technique which is called the lemmatization. So there are various types of stemming algorithms, like Porter stemmer, snowball stemmer. These are all the types available for lemmatization. It would be in an advanced way. It would clean up the text in a systematic way. So the words, based on the matching words with the language dictionary, it would clearly remove the words like prefix and suffix kind of stuff. It would find the exact match and remove the words. So it is not like stemming on the first step we mentioned. So the lemmatization is the advanced step. Handling abbreviations and acronyms. So this will also we have to do while clean up the text. So here I have mentioned our NLP is the abbreviation of NLP is natural language processing in a text. So similarly, I have also added a couple more examples here. DR will call it as a doctor, right? So similarly, this is abbreviation, like we can use the first letter of each word. So we cannot call that word as a name. We cannot call as a word, like we have to pronounce it in a single letter. Like for example, NLP only we used to pronounce that, but when we go for acronyms, we could that first letter of each word would define a new word. Here NASA I have given, UNESCO, so radar, these things and all, that would form a new word from the first letter of each word of the sentence. So this is what now we have to handle abbreviations and acronyms where and all there in the text for the model. So sometimes this would be a challenge, because same acronym and abbreviation, they will be having different expansions. So that would cause ambiguous between the expansions. So that would be a challenge here. So there are a couple techniques they have used. The first technique, dictionary based approach. So as you all know, dictionary contains like key value pair kind of stuff. So based on that, it would go and fetch the exact match from the dictionary. So here I have mentioned NLP, natural, it will go on fetch the expansion for NLP, natural language processing, based on the dictionary lookup. Technique 2, this is completely, we have to train the machine, like a machine learning based approach. So train a model to predict the expansion of abbreviations or acronyms based on the context, because based on the context, the meaning of the expansion of the acronym or abbreviation would vary, right? So based on that, the system would go ahead and find the exact expansion for the acronym or abbreviations where and all it finds. So this is for technique 2. So I'll move on to the next slide. So here I have mentioned a few more techniques. So we'll try to demonstrate using these techniques in a quick example using Python program. So I have tried that. We'll quickly go and check that one. Are you able to see this Jupyter notebook, right?
Yes, Uma.
Yes.
So yeah. Here actually I put everything in a single program. So I have also tried couple things in different small program as well, but you could go ahead. Most of the things here we have tried using the built-in functions. So you all know NumPy and pandas and all, mainly these two libraries we have used for data manipulation, data manipulation, and then analysis purpose. We will be using these two libraries. So you all aware of these two libraries. RE again, as I mentioned, it is a regular expression, as well as to clean up the text. It is a default one which is used frequently to clean up the text. The rest of this is NLTK, so the natural language toolkit. So we'll use this again to clean up the text. We could also bring the stop words and these things and all from the existing library. So from NLTK, we have imported all these things. So I have already downloaded these, so I didn't do it again here. So I have commented out these. So this is an example. Email.csv. I have downloaded it from the Google. Like this would contain a lot of emails. I could say it's a sample data set. I could download. I can go ahead and download from Google to do some data analysis. So here. From this CSV file, so I have only taken the two columns like text and spam. So I have extracted those columns. But again, I'm gonna add one more column here with the class that would indicate like where and all it finds a spam. It would go and set the value as Boolean value as true 1. So again, the third column also we have manipulated here, like where and all the class finds 1. We have set that as spam, else ham. So these kind of small manipulations we are doing here to retrieve the clean data from the noise data. Like, so when we feed the noise data to the program, and it will clean up based on these techniques. We have applied all these techniques so to clean up the text. Once applying all these things, we would get the result. I've only brought 10 records here. So usually that CSV file contains around 5,000 plus records. So here, if you all remember a punctuations thing, we have to remove punctuation from the text. And then tokenizing the words, like here we have applied a word by word tokenization. Stop words. Again, this is for a general thing I have mentioned, like English, but we could go ahead and apply, or what I've shown in my PPT. We could go ahead and apply those stop words and remove all those stop words. So similarly for stemming and lemmatization. So as you all know, like stemming would sometimes it would cause issues. It would remove unwanted thing from the words. So for that, to avoid that, we'll go for lemmatization when we go for a production and other things and all. So these and all, like it's a quick program. I have also tried. So a couple more things I have tried, but I know this is here. Yeah, as I showed in the previous screen, the same way I have tried section by section here. The first step I have tried only the top 10 records I've taken. So see here we have a lot of punctuation things and like stop words, this, that, and all. So this we could see a lot of spaces, white spaces here. So how, at the end, while applied all these techniques, how we are getting as a clean text is the result here. So I have tried here first to lower, and then I have remove punctuation, like for the same first record only I've taken and applied all these things. This is somewhat different, like I have download these stop words from the library. So I've tried these things. So yeah, you could go ahead and try each technique in a different example. Even you could use your own example like this. So and try this out. So that was the quick stuff from my side for the session today. Yeah, one second. Yeah, I'm good with my stuff like I have done. That's all I have for the session today.